I'm not sure why I'm talking over people. For the first two problems that we have on here, it's going to be back to that just quartic factoring. But we're not going to find the factors that go into 32. What we need to keep in mind, guys, is that we have to make sure that it's set equal to 0. So our original equation has to equal 0. So right now it equals 32. So how am I going to get rid of that 32 so that it's 0?
Minus 32.
Minus 32. And we did that back in chapter 5, guys. So this is x to the 4th minus 4x squared minus 32. So Jacob, I still am listing the factors of 32 like you mentioned, but I'm trying to get a negative 32 this time, which just affects the signs that I'm going to use. In chapter 5, we would have broken this down into x times x. But because this is x to the 4th, what do we have to break it into? X squared times x squared.
I already had that.
You already had that? Excellent. What are my signs for a negative 32 going to be?
Positive and negative.
Positive and negative.
You want to put the bigger number in negative.
Good job. Because we have a negative 4, we know this is where our larger factor is going to go. So what are all the factors of 32 that we can look at? 4 and 8, right guys? 3 didn't divide in there, 4 does. We know 5 doesn't, 6 doesn't, 7 doesn't, and we're right back to 8. It has to equal negative 4. So the 4, 8, and as Zena mentioned before, we have to make sure that the negative is with the 8 because the larger number needs to have it. That is one of the types of factoring you're going to need to be able to do on the quiz and throughout today's homework. That's part of the 6.4C notes. Zena.
Is this our final answer, or are we going to do it like how we did in chapter 5?
Exactly. This is not our final answer. This is just the factoring. So we set it equal to 0. We then factored it. And what I had to remind third hour was, is you have that yellow sheet, guys. I'm not doing enough examples with you to show you every type of factoring from chapter, or from 6.4. Okay? From the first, the yellow sheet.
Oh, that. I accidentally left
What are you, what?
It says what's minus yellow.
Oh, dash yellow. Should I put like colons? Yellow sheet. All right. The colon yellow sheet is what you need to have out. But as Zena kind of baited us with there, we're not done. We have to set each factor and then solve. So we're going to set it equal to 0 and solve. Because what we started out in chapter 5 was, is we said if this equals 0, then either x squared plus 4 equals 0, or x squared minus 8 is equal to 0. These are pretty easy equations to solve, ladies and gentlemen. Undo the operations. How do I undo adding 4? Subtract 4. How do I undo squaring? Square root. But remember, I only want real solutions. So can I take the square root of negative 4? No. So ladies and gentlemen, this will not give us any solution. Some of our equations we won't be able to solve today because we only want real solutions.
Totally right.
I just cross that one off and wait to see if my second one gives me a solution. If my second one gives me an imaginary solution or a negative, then we would say no solution. But I'll get the answer key out and double check. Every one of our problems should have at least one solution to it.
So the reason why we didn't do that one is it's a negative?
Because you're taking the square root of a negative. Good job. But here we have a positive 8, guys, so I am going to be able to take that square root. Now, I see a lot of people grabbing their calculators. That's fine. But what did it give you? A decimal, which means you're going to break that up into 4 and 2. And what does 4? Oh, more in chapter 5. What does 4 break into?
2 square root 2.
Hey.
It's not just 2 squared to 2, ladies and gentlemen. What did I put in front of it? The plus and negative, the plus and minus.
Did you say your calculator to do that for you?
It will, yes, it will do imaginary ones for you if they're perfect squares, but because if you look back at the directions, it said we just want real solutions, we get to ignore all of our imaginary ones. No, you can't get a calculator to do this for you without You have to write a program for it to do that, and I'm not very good at programs. I can write a very basic program, and that's
Maybe I
it.
should learn how to program.
It's a good job skill, but I'm doing okay with just teaching, so I don't think I need to gain any more skills. I'm old. Yes.
Will all our answers be
No, they won't all be in radical form. Let's take a look here and see what happens. Are we ready to go, guys? Is it equal to 0? No, so I have to subtract 14x to the third. Be careful, guys. It's not always just going to swing to the end of the problem. It needs to be put in standard form, so I need to look at these. 3 would go after the 5, but before the 1x, or before the x to the first. So we're going to basically minus 14x to the third in the middle. So I have 2x to the fifth, minus 14x to the third, plus 24x. So we did our set equal to 0. We're going to factor. Now this time I'm not going to say minus yellow. I'm going to tell you GCF. Don't forget
Greatest common
that.
factor.
Exactly. Greatest common factoring is part of that factoring process. So when we look at this, guys, most of you notice what divides into each of those terms. 2. So I'm going to take a 2 out. 2.
And you can also
But it's
take an X out.
2. Exactly. Don't stop with just the 2. You have to look at what's left there, and so, or look at our variables, and so we also have an x there. X. All right.
Oh my God.
So ladies and gentlemen, I have this 2x here, and this 2x is going to follow us throughout the problem. But right now, I need to factor this because it looks similar to what we just had in number 1. What's x to the 4th going to break into, Ian? What's x to the 4th going to break into? X squared and x squared. Beautiful. What would my signs be here? Good job. I couldn't even get a name out. Parker Shisaja, because you were the one I was going for. You knew it was minus though, didn't you?
Yep.
You knew what the signs were, didn't you?
Oh, I was just talking now that I was up.
Oh, okay.
But I was trying to stare and say that.
You would have gotten an answer. No, you would have gotten an answer. I feel confident. 12.
1, 3.
I can't even write these down fast enough. You guys are great at factoring. 3 and 4, or 4, 3, it doesn't matter.
Don't forget to do 2X and
All right. What we need to keep in mind, ladies and gentlemen, is we have to set the factors equal to 0. And what we need to remember is that every x factor has to be set equal to 0. And so because we're setting the factors equal to 0, I have to look at that GCF. Did our greatest common factor have an x with it? Yeah. So 2x.
Are you recording?
We used to. How is? Why didn't you? Why don't you let it record?
Look, get out of here.
I know. So, I miss you.
I know, what the heck? I never see you anymore.
Tila.
Hi, Danton. You needed that, thank you. Ladies and gentlemen, Venus X, why don't I distribute it back in? Because if I distribute that in, I'm going to get x to the third, and I can't solve x to the third without factoring. So we have to leave it, the best we can do is x squared. Now, this is really easy. I wouldn't want to multiply it in, because how do I undo multiplying by 2? Divide by 2, what's x going to equal? 0. Those greatest common factors are just going to give you a 0 solution there. But here I'm going to add 4. So we get x squared equals 4. And this is where it's not going to be a radical. It's just that plus or minus 2. And so Zena had asked, are all of our answers going to have radicals? Not if it's a perfect square. And I believe your first problem today on your worksheet involves perfect squares. So we're not going to have a radical there. But here I'm going to add 3, correct? That's how I undo subtract 3. So I'm going to add 3. X squared equals 3. I can still take the square root. It's simply not a perfect square. Pretty good, guys? Are we okay there? answers? 1, 2, 3, 4, 5. Okay, with all 5 of those answers.
Math.
You need to quit taking McKean's class.
I'm not taking this class.
That comes from McKean's class, is what I've heard before. Okay. No, we're all, guys, this is all going live online for us, so this is great.
Math is the devil.
I don't have to send this directly to your mouth, Parker. All right, here. Yeah, well, we're recording it, and then I put it up on. I'll have to cue, tell her where to cue into.
Can I give a shout out to my mom?
Really quick.
Shout out to Mr. Benson.
I might have to snip this middle part out. All right, here we go, ladies and gentlemen. The first thing we're going to look for, before I can count how many terms are there, I'm going to look and see, do I have a greatest common factor?
Yep.
Hopefully 5 divides in there. 5 and X. Check your last term. Look at your last term. Does your last term have a variable? Then that's your greatest common factor for the variable. It's not the 160, it's simply the last term will give you your variable, so it's going to be x. Take it down to x to the 4th minus 5x to the 3rd plus, no, I'm sorry, not 5x, how about 4? No. I am beyond exhausted right now, so I need some help. Is this 32? I'll be better tomorrow. Alright, here we go, ladies and gentlemen. We have 4 terms. Go to your little yellow sheet, or your minus yellow, and you'll notice that it says factor by grouping. That factor by grouping is just greatest common factors. What's the greatest common factor of x to the 4th? And what's the exponent going to be? X to the 3rd this time. Why? Because what's the smallest exponent there? You use the smallest one in that group. Guys, remember what I said. Look at your last term. Look at your last term, and that last term will tell you your variable. And because we're just focused on these, it's x to the 3rd. I need to divide that out, and that leaves me with x minus 4. I need this now to be x minus 4. So what is going to be the greatest common factor of 8 and 32? It has to be an 8. A couple of reasons. Why is because I said 8 times x gives me the 8x. Yeah, combine your inside. So x minus 4. X minus 4 is going to come here. And then I have x to the 3rd plus 8. Zena, I'm working on it. I can only write so many things at a time. So give me just a minute. Well, and I can only write with one hand at a time on the board anyways. Ladies and gentlemen, we are not ready to solve this yet. This should look familiar to you. Have we learned how to factor those? This is a cubic. Use your sheet to help you there. Your A value is x. Your B value is 2. So this cubic, which some of the problems we're going to do today, guys, just involve factoring cubics. It doesn't show up in the middle of the problem. It's going to be x plus 2. So have your yellow sheet out to have that formula. Times x squared minus 2x plus 4. The 5x came from our greatest common factor, correct? X minus 4 came from here. X cubed plus 8 gave us an A value of x and 2. This is the sum of cubes, guys. I've memorized the formula. It's not a minus, it's plus.
So we do X minus 4, wouldn't you break that down?
I'm not done solving yet, Zena. I'm just trying to show everyone where my factoring is. Give me a minute. I haven't set up any solving yet. I need to make sure everyone's in factor. I'm glad you got this, and if you want to work ahead, have at it, and you can compare your answers to mine.
Okay.
This came from my yellow sheet, guys. I memorized the formula. If you don't have this formula memorized, you have to follow your A plus B times A squared minus B squared plus B squared. You have to get it off your yellow sheet, guys. That's why I put it on the first column. All right, Parker, you took your glasses off. Are we done?
Oh, no.
Oh, okay. Jesse.
I said how many do you like?
I took the cube root of x to the third, which is just x, and then I go to my calculator and I do that math 4. This is the cube root of 8, gives me 2. So what I'm doing here is cube roots. Now, Jesse, because I've taught math long enough, I have these memorized, so I know 8 goes down to a b value of 2. Okay? But you can find those on your calculator. Now we're at the point that Zena was trying to get me to. Each factor is set equal to 0. All I did on this problem, guys, oops. Now I did this one specifically, ladies and gentlemen. 1, to practice greatest common factors. 2, to practice factor by grouping. And 3, to practice the cube roots. That's all the factoring that we've seen in lesson 6-4 at the beginning, okay? So I've done a quick review. Notice I set 5x equal to 0. I set x minus 4 equal to 0. I set x plus 2 equal to 0. In your cube roots, ladies and gentlemen, this last factor will never solve, okay? So with the cube roots, it's that part of it is automatically a no solution, okay? Sam.
I get it. You explained it.
Okay. So do you guys see why now I had to do that cube root problem in the middle of it? I wanted to try and, you will not, I don't think there's anything like this on today's worksheet where there's this many levels of factoring, okay? But there will be a cube root one that you need to do. Now we're not done. Hopefully you guys all divided by 5 and got x is equal to 0. Hopefully you added 4 and got x is equal to 4. And subtract 2, did we get negative 2? Good to go? All right, or at least good to get started. Let me stop the recording.
Shout out to my mom.